Okay? Most of the fats that we consume are going to be probably somewhere from 18 to 22 carbons in length. 18 to 22 carbons in length, give or take a few. If you have things that are shorter than that, like 10 to 15 carbon length, they usually are either artificially manufactured or sold to you as a bodybuilding supplement. They're called medium-chain triglycerides. Medium-chain triglycerides are fats that are shorter length. They're like 10 to 15 carbons in length. All right, but most of the dietary fats you eat are going to be somewhere between 18 to 22 carbons in length, somewhere around there. In any case, on this is going to have, carbon likes to have 4 sticks on it at all time. Okay, carbon likes 4 sticks. At the other end of this, it's going to be one of these deals, with or without the hydrogen. Okay, if it doesn't have the hydrogen, it'll have a negative charge to it. In any case, on there, on each of these sticks is what? On each of these sticks is hydrogen. You know, and this is so on. This might be a double bond, and this one, I put the other, it would have been like that, right? And then up here would be either an H or maybe not an H, whatever. In any case, it's a fatty acid. It's a fatty acid. This is the acid part. This is the acid part. Hydrogen and oxygen out there, that's the acid part. Okay, like amino acid, hydrogen, oxygen, that kind of thing. This one, because each of the carbons is blocked off or attached to a hydrogen, except for the terminal carbon, do you think that's saturated or unsaturated? Saturated. It's saturated. It's saturated with hydrogen, right? It's saturated with hydrogen. Okay. Say I draw this thing like this now. And so on. And on each one of these places, we have this. And this has, you know, the oxygens and maybe or maybe not a hydrogen, blah, blah, blah. How is this one different than this one? What's different about these two?
Lacks some of the hydrogen.
What's present? There's a double bond present. Carbon-carbon double bond. Remember, carbon likes 4 sticks on it. If the sticks have to come together like an equal sign, well then so be it. It likes 4 sticks. However, in doing that, what happens? You're missing what? You're missing hydrogen, aren't you? Okay? So, is that saturated or unsaturated? Alright, is it monounsaturated or is it polyunsaturated? How many carbon-carbon double bonds are there?
Just one, so it's mono.
It's monounsaturated. So a monounsaturated fat is a fatty acid chain that has 1 carbon-carbon double bond in it. Okay, has 1 carbon-carbon double bond. What's polyunsaturated? Yeah, I mean you go and maybe you got one here, you got another one there, and so on. Remember 18 to 22 carbons in length, I'm not drawing the whole thing out, but there's more than one carbon-carbon double bond. Free fatty acids. Free fatty acids. These are free fatty acids. Free because they're just by themselves, right? This is a saturated fatty acid. This is a monounsaturated fatty acid. This is a polyunsaturated fatty acid, right? It would have all the little hydrogens every place. I didn't bother to draw them in. Okay, blah, blah, blah. So anybody not clear? Saturated, monounsaturated, polyunsaturated. More than 1 carbon-carbon double bond. Okay? If I put glycerol, which is a 3-carbon molecule, hydrogens on it, and OH, or hydroxyl group, OH, OH, OH. Well, all these O's and H's get together, and what do you think comes out? What did we say before? What was that called when you pull water out of something? Right? Condensation reaction. It's a condensation reaction, right? So if you have a glycerol molecule, which is a 3-carbon molecule lying this way, attached to these guys, what is this now? 1, 2, a triglyceride. That represents a triglyceride. If you take one of these out and there's only 2 attached to that glycerol molecule, it's a diglyceride. And if you take 2 of them out and you only have 1 left, it's a monoglyceride.